Yes. So good afternoon, dear students.
Good afternoon, ma'am.
Yeah. Okay. So, so last class we had started with right D and block elements. So, what are the things we have discussed in our previous session? So, just we'll revise once. Okay. So, what are D block elements? Yet, so first we are discussing about the D block elements, right? So, the elements. Okay. So, the elements which are partially filled into the D subshell. Okay. In their atomic or the ionic state, they are termed as D block elements. So, what is the general electronic configuration of these D block elements? The general electronic configuration of this D block element is N minus 1, D 1 to 10, Ns 1 to 2. Okay, so this is the, so electrons are getting filled into the penultimate shell. Okay, and it's gradually gets filled with the, as the number of electrons are increasing in their increasing atomic number, right? So then we had started with the key points. Okay, so we have seen what are the general properties of transition elements. Okay, so the different properties. So we have discussed this. Then we have discussed about the metallic character. Then what is reducing power? Okay, then density. So today we are going to start with the melting and boiling point, right? So we had started with melting point. So I had plotted a graph, right? I had plotted a graph of different different elements of 3D, 4D, and 5D series, right? So just a second. So yes. So I had plotted a graph, right, of 3D, 4D, and 5D series of transition elements. Okay. So we saw that the melting point was maximum, right? The melting point was maximum for the D5 electron. Then we saw that the metals, okay. So the plot was versus this melting point versus your atomic number. So the metals of second and third series, as you could see by the graph, that they had a greater melting point. Okay, as series. So these were the things which we had seen in our last class. Then we were discussing something called as shielding effect. Okay, we were discussing something called as shielding effect. So let me tell you again what is this shielding effect. Okay. So we're discussing about the shielding effect. Okay. So you know that protons are at the what? Protons are that is a nucleus is in the center and it consists of what? The positive charge, which is your protons, right? Then so protons are embedded in the center, that is it is termed as nucleus. Then around this nucleus, what are revolving? The electrons are revolving in the form of the orbits, right? So these are the different subshells, right? Now S, P, D, F, right? So these are the different subshells. As we are filling up the electrons, okay, first the electrons will go into the 1s2, then it will go into 2s2, then 2p6, right? 3s2, 3p6. So this is it. It goes according to the Aufbau principle. So you might have studied about Aufbau principle in first year. So how the filling up of electron takes place? It takes place, okay, according to Aufbau principle. So when you go into the first, okay, first quantum number, this one, okay, first shell. So here the number of electrons accommodated can be 2. Okay, then maximum next is how much? 8. Okay, so 8 number of electrons, maximum it can accommodate is how much? 3, 4, 5, 6, 7, 8, right? Okay, then subsequently it increases. Okay, so subsequently, so 2, 8, 8. Okay, so like that, the filling of electron takes place around this your nucleus. Okay, now what is this shielding effect? What is this shielding effect? Suppose now the last electron, where it is filled, the last electron is outermost shell, right? The last electron is filled in the outermost shell. Now, what is happening about your shielding effect? Okay. Now here, as you're at as you're moving into the 3D series, okay, that is how the electrons are getting filled. For example, scandium, titanium, palladium, chromium, manganese. Okay, then Fe, cobalt. So what is scandium? Okay, titanium, chromium. Then your this is 26, this is 25, 24, 23, 22, and 21. Right, and this is 27. So like this, it subsequently what is happening? One electron is increasing, right, as you are processing here. So like that, as you're moving, what is happening? One electron is added into the last shell. Right. Now, what will happen? What is this shielding effect? Okay. So this so what is happening in general, the atoms and ions of the same charge in this given series, okay, you can see that there is a progressive decrease in the radius. How the radius will decrease? Because there is as you are proceeding, okay, as there is an increase in atomic number. Why? Because as you are adding the newly added electrons, okay, as you are adding, as you are proceeding with the increasing atomic number, the newly added electrons are added into the d orbitals, okay, and it will shield your ns electrons. It will shield your ns electrons, okay, from the nucleus force of attraction. Means what? This, whatever the nucleus is there, whatever the positive charge is there, what it will do now in this electron system, you can see two types of forces. Okay, one will be a attractive force, one will be a attractive forces, and another will be a repulsive forces. Now, what do you mean by attractive forces? Whenever you have a unlike charges, okay, you know that plus and minus charge. Okay, suppose I have a positive and negative charge, so they will attract each other, right? That is, they are said to be unlike charges. And whenever you have like charges, suppose negative negative or positive positive, what is possible? Repulsive is possible, repulsion is possible. Now in this system you can see that there are two types of forces acting. Okay, one will be a attractive force. So attractive forces is between what? The attractive forces is between the nucleus, okay, the nucleus which is positively charged, and the electrons which are negatively charged. So you know that protons are what? Proton are positively charged, right? And electrons are your negatively charged, and neutrons are neutral charge. Okay, so we are not considering neutrons, only we are considering here what? The protons and electrons. Now here the positive charge, the positive forces is between what? Your that attractive forces is between the protons and the electrons. Okay. Now, as you are adding the electrons in the outermost shell, what is happening? What is happening? The positive, whatever the forces are there. Okay, whatever the this, what is this? Your protons are there. These protons, what it will do? It will tend to pull the electron towards itself, right? It will put the force. So there will be a attractive forces. So similarly, it will try to pull the electrons from the outermost shell towards itself. Okay, so there is a presence of attractive forces. So as the electrons, as the protons are pulling the, as it is pulling the, so there is an attractive force between the protons and the electrons. What is happening to the size? The size of the this what your okay, the size of the, it is going on reducing. The size is getting, so that there is a decrease in size observed. Okay, so this is called as shielding effect. So this is called as what? This is shielding effect. So two types of forces at so between these electrons and the electrons, what types of forces are there? There is a repulsive force, right? So there is a repulsive force, but more than this repulsive force, the attractive forces are playing important role. Okay, so it is tending to pull the electron towards itself, and as a result, what is happening? As a result, you can see there is a decreasing size. So this forces, this effect, okay, which is experienced by the nucleus on the outermost shell is called as the shielding effect. So this is called as what? Your shielding effect. Okay. So this initially the shielding effect is seen by the electrons. Okay, because the valence electrons, that is valence s electrons are it is the whatever the s electrons are where s electrons are placed. S electrons are placed nearer to the your nucleus, right? So the so this s electrons are dragged, or they are attracted more forcefully towards your nucleus as compared to that of the d electrons, and thus what is happening to the radius? The radius is decreasing. The radius is decreasing. So as the number of d electron increases, what happened to the shielding effect? Shielding effect also increases. So what is happening to the shielding effect? The shielding effect also increase. Okay, and thus it will balance whatever the attractive forces are there from the nucleus. It will be balanced, and the atomic radius, it will remain constant. Okay, so this is about your the effect of melting point and boiling point. Okay, now further what will happen? Okay, further as you go, so this is you can see in the 3D series. Okay, this is the case where you can see in the 3D series. Now okay, now further as you go down the group, that is the 4D series. When 4D series come into picture, 5D series come into picture. Okay, so as you are going down the group, what will happen to the size? Yes, generally you know that you have studied this in your first year. Okay, atomic radius as you proceeds in the period, it will decrease. Why? Because of effective nuclear charge, or it is due to shielding effect, right? Due to the force, that is a force experienced by the nucleus on the outermost electrons. Okay, the size of the radius decreases as you are proceeding towards the left side. Now what is experienced as you go down the group? Yes, what will happen to the atomic radius as you move down the group? What will happen to the size of the atomic radius? It will increase. Why? Because as we are moving down the group, new addition of shell takes place. Okay, addition of new shell. Okay, you are adding new shells, right? So because of that, what is happening to the atomic radii? The atomic radii, it increases. So what you can see when you're moving from 3D to 4D series, okay, when you're moving from 3D to 4D series, what you can experience is that there is a increase in atomic radius. There is a increasing atomic radius. But when you move, okay, from 3D to 4D, when you are moving, you can see that there is a increasing atomic radius. But 5D element, but when you reach 5D series, they have almost same atomic radii. Okay, they have same atomic radii. You can experience that they have same atomic radii as that of the 4D series. So when you're moving from 3D to 4D, what you can see, there is an increase in atomic radii. But when you move from 4D to 5D, you can experience that the 5D electrons, okay, or the elements, they are having same atomic radii as compared to that of the 4D series elements. Why? What is the reason? It is due to the intervention of 4f orbitals, okay. So as you are moving from 4D to 5D, there is a what is present? There is an intervention. Okay, you can experience there are 4f orbitals. So there comes into picture your 4f orbitals. So due to the presence of that is a intervention of 4f orbitals. Okay, so before 5D electrons, what has filled? Your 4f electrons are filled. So because of that, there is a decreasing atomic radius because of imperfect shielding of 4f electrons. So because of the imperfect shielding, so there is something called as imperfect shielding of 4f electron, because before entering the 5D series, the electrons are to be filled in the 4f electron. So because of this presence of 4f electron, intervention of 4f orbital, there is a decrease in atomic radius. So because of imperfect shielding of this, because of the imperfect shielding of 4f electron by another, so this causes something called as lanthanide contraction. Okay, this is called as lanthanide contraction. So what do you mean by lanthanide contraction? Important. Mark this as important. What is lanthanide contraction? So the intervention of 4f orbital. Okay, so the intervention, okay, the intervention of 4f orbital, which result into, okay, that is the filling of a 4f orbitals result in decreasing atomic radius, and because of imperfect shielding of 4f electrons, this is called as lanthanide contraction. Okay, so because of this reason, 4D and 5D series, okay, elements of 4D and 5D series, they have similar atomic radii. They have similar atomic radii. So the elements from 4D series, that is zirconium, it is having 160 picometer as the atomic radii, and that of hafnium is having 159 picometer. What is the reason? Yes, so like this the question. So from inorganic chemistry, okay, you will be getting give reason type question. Okay, so one question can be asked like this: zirconium and hafnium are having same atomic radii. Give reason. Yes, zirconium and hafnium are having same atomic radius. Give reason. So why? What is the reason? It is due to lanthanide contraction. That is due to intervention of 4f orbitals. Okay, 4f orbitals. Okay, so there is a, you can experience decrease in atomic radii. So because of this reason, hafnium and zirconium are having same atomic radius, because 4D and 5D series, the elements are having same atomic radii. Okay. So this is about your lanthanide contraction. Very important, lanthanide contraction as, okay. So after that, so let me tell you, so which are the elements? So let me tell you the elements. So let's see the, okay, so let us write the, we'll see the general properties. Okay, first we'll see the general properties of 3D series. So let us see the, so which are the, this, okay, 3D series elements. So let me tell you. So the electronic configuration of 3D series. So first is scandium. So which are the elements? Titanium, palladium, chromium, manganese, Fe, okay, iron, cobalt, nickel, copper, zinc. Atomic number 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Electronic configuration. So this is what will be the electronic configuration? Argon 3D1 4s2, then argon 3D2 4s2, same 3D3 4s2. Then what is the manganese? Can anyone tell me? Manganese. What is the
3D4?
Here manganese is 25. Okay. Now if I write it like this, 1s2, 2s2, 2p6, 3s2, 3p6. Okay. 3D. So just see how many count it. So 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So again 19, 20, 21, 22, 23, 24. Right. So I have to fill how much? 6 electron. So can I do it like this? 3d5 and 4s1. You know that whenever we are talking about d orbitals, okay, so if there are d5 system, okay, that is d5 system means it is a half filled electrons, and you have a d10 system. D10 system means completely filled electrons. So they are said to be more stable as compared to the, okay, so as compared to the other system, when you have D5 and D10 system, they are more stable. So I can, so the general electronic configuration of Mn is 3d5 and 4s1. Okay, so this can be a question. Very important. So remember the, sorry, I have scandium, titanium, palladium, chromium. Yes. Okay. So like this. Understood? Is it clear? Next is then remaining, write it as it is. So this is argon 3D. Eighteen, 19, 21, 22. 18, 19, 21, 22. So this is for 18, 19, 20, 21, 22, 23, 24. So this is for chromium. Okay, we have written it for chromium, not for manganese. That only. Okay, so this is 4s2. So this is scandium, titanium, palladium, right? So now we have written this for chromium. Okay, chromium. So chromium is 24. So let's see for chromium. First, we'll write for chromium. Okay, we'll see for chromium. We have to write for chromium. So argon is what? 18. Argon is 18. So remaining how many? 18, 19, 20, 21, 22, 23, 24. 6 electron. So we can do it as 3d5 and 4s1. Okay, we can do it as 3d5 and 4s1. Now, manganese. Manganese again 25. So argon is 18, 18, 19, 20, 21, 22, 23, 24, 25. So 7 electrons. So it will be again 3d5 and 4s2. Okay, so what I have to do, I'll do it as like this. Okay, so argon 3d5 and 4s2. So because d5 system and d10 system are said to be stable system. Then Fe 26, again argon is 18 electrons, then again remaining, so 3d6. Okay, then comes 3d6 and then will be 4s2 because the maximum number of electrons filled in this is how much? 2, right, in S. Then is cobalt. Cobalt is 27. So argon 18. Then 3d7 and 4s2. Okay. Then nickel. Nickel you write for nickel. Argon 18, 3d8 and 4s2. Then copper. Yes. Now you tell for copper. So again copper also it will change. For copper also it will change. So copper is 29. Okay. So write argon 18. Okay. 18, so 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. So again, 11. Okay, 11. So how I'll write? I'll write it as 3d10 and 4s1. Okay, so this is the change. So chromium and your this what chromium, the electronic configuration of chromium and copper. Okay, they ask you. So this is very important. Mark this important. Okay, it will change. It will change. So when you are filling the electrons, so it will see that the stability. So D5 system and D10 system. Then zinc, how much? Zinc is argon 18, 3D10, 4s2. Okay, so these are the electronic configuration. Is it clear? Yes, so these are the electronic configuration. So what are the general electronic configuration of this 3D series? It is argon, 3D 1 to 10 and 4s 1 to 2. So this is the general electronic configuration of your 3D series. Okay, very important. So chromium and copper is showing exceptional electronic configuration, that is D5 and D4 1 and 3 D10 and 4s1. Because why? What is the reason? For extra the stability, for extra stability, that is here it is half filled, here it is half filled, because for extra stability, we see half-filled electrons and completely filled electrons. Okay. So we have here completely filled D10 system, that is subshell, and here we have a half-filled D5 system. Okay. So this is about your electronic configuration. So next we'll see the ionization enthalpy. What do you mean by ionization enthalpy? Yes, what do you mean by ionization enthalpy? So in the last class, I had told you the definition of ionization enthalpy. Yes, ionization enthalpy you have studied in first year. Okay, let me clear this electronic configurations. I'll just keep the elements. Yes, what is ionization enthalpy? It is a minimum
The
energy.
amount of energy that is required to remove electron from the outermost shell.
Yes. So the minimum amount of energy which is required to remove the electron from an isolated gaseous atom. Okay. So this is termed to be your ionization enthalpy or ionization energy. Now, when we see the first, so whenever we are comparing the first ionization energy and second ionization energy, okay, which is more? First ionization will be more or second ionization will be more? Second ionization will be more as compared to the first ionization enthalpy. Okay. Now, in general, what will happen to ionization enthalpy as you're moving across the period, that is your 3D series, okay, the ionization enthalpy will increase. It will increase with the increase in the nuclear charge. Okay. So what so there are so what is the so you can see the values are given. So this is the 631, 656, okay, 650, 653, then 717, 762, 758. So what you can see here generally, yes students, what you can see that there is a increase. Okay, so there is a increase in ionization enthalpy. So this is the first ionization enthalpy. So I'll give you the second ionization enthalpy values. So 1235, 1309, then 1414, 1592, okay, 1509, 1561, 1644, 1752, 1958, 1735. So what you can see as compared to the first ionization enthalpy, second ionization enthalpy is the values is more. Okay. So this is about ionization enthalpy. Next is oxidation state. So let us see. Next is oxidation state. Okay. So next is oxidation state. So what are the general oxidation states? So scandium, titanium, vanadium, chromium, manganese. Okay. So we have seen the general electronic states. So we'll see the oxidation state. So scandium, so it will go maximum. Okay, you are. So scandium, titanium, vanadium, chromium, manganese. Okay. Then we'll see the oxidation state. So scandium, we saw it as 3D1, 4S2. Okay. What is the oxidation state? 3D2, 4S2. Then 3D3, 4S2. 3D5, 4S1. Then 3D5, 4S2. Yes. So what is the oxidation state of scandium? Maximum number of electrons can be given as 3. So it is +3. Then titanium, the maximum number of electrons given is 4. So it can show +2, +3 and +4. Okay. Then here the maximum number of electron given is 5. So it will show +2, +3, +4 and +5. Here the maximum number of electron given is 6. So it will show from +2 to +6. Then here how many? 7. So it will show from +2 to +7. So these are the different variable oxidation state which is shown by these first 5 elements. Okay. So let us write the next. Next is iron, copper, cobalt, nickel, copper, and zinc. Okay. So the electronic configuration is what? 3d6 4s2. Then this is 3d7 4s2. Then here is 3d8 4s2. Then this is 3d10 4s1. And this is 3d10 4s2. Yes. Can you tell me the oxidation state? So iron, it can show +2, okay, +3, +4, and +6. So these are the oxidation state shown by iron. Then cobalt can show +2, +3, +4, and +5. Then nickel can show +2, +3, and +4. Copper can show +1 and +2. And zinc can show only +2. So these are the electron oxidation states which are shown by the D block D series, that is 3D series. Is it okay? So all these transition elements, okay, you can see that the transition elements, they show what it is said to be variable oxidation state. Variable means what? Variable means different oxidation state. So you can see that the this what your transition elements, they are showing different oxidation state and they are differing from each other by 1 unit. Okay. Why? What is the reason? The reason is that there is a energy difference between the ns and n-1d orbitals. So these are two different orbitals. So the energy difference between the ns and n-1d is very small. So it is very small. So the energy difference is very small. So because of this reason, they are differing only by 1 unit. So they are differing only by 1 unit. And hence the electrons, okay, from both these orbitals, they are utilized for bonding. So we can utilize these electrons for bonding. So, so these are the oxidation, different variable oxidation state. Okay. So this is about the this property, third property, that is oxidation state. So next we are going to study about the next property, that is magnetic property. Okay, next we are going to study about what? Magnetic property. So most of the electrons, okay, most of the transition elements, as you can see, as we have seen the as we have seen the general electronic configuration, okay, the metal ions are paramagnetic because you could see that there was a presence of one or more unpaired electrons. So most of this transition metal ions, they are paramagnetic in nature. What is the reason? Because of presence of one or more unpaired electron. So as you know, what is paramagnetic behavior? Paramagnetic behavior is shown due to the presence of unpaired electrons. Okay. And hence these are attracted by what? These are attracted by the external magnetic field. Okay. So paramagnetic behavior, it is attracted to what? It is attracted to the external magnetic field. So this paramagnetic behavior, it is how it is measured? It is measured in terms of magnetic movement. Okay. It is measured in terms of magnetic movement. So it is the unit is magnetic moment, which is given by mu. It is given by mu. Okay. And it's what is the unit? The unit is Bohr magneton. What is the unit? The unit is Bohr magneton. Okay. So how you can calculate? So we can calculate the magnetic moment. Okay, we can calculate the magnetic moment, and the magnetic moment can be calculated as mu is equals to square root of n into n plus 2. Okay, square root of n into n plus 2, where n is the number of unpaired electrons. What n is? N is the number of unpaired electrons. So this tells you the magnetic behavior of transition elements. So transition elements, they will exhibit magnetic property. What is the reason? Due to the presence of one or more unpaired electron. Okay. So most of the elements, they are showing paramagnetic behavior, and this paramagnetic behavior, it can be calculated in terms of magnetic moment. Magnetic moment, what is a unit? It is Bohr magneton, and it can be calculated by mu is equals to square root of n into n plus 2, where n is the number of unpaired electron. So what will happen? The magnetic moment values, okay, it will increase with the increase in the number of unpaired electrons. Okay. So this is about the your this magnetic behavior. Okay, I'll show you one example how to calculate the unpaired number of unpaired electrons. Okay, so let us solve it here. Now suppose I have scandium plus 3. Okay, scandium plus 3. Can you tell me the number of electrons in scandium when it undergoes plus 3 oxidation state? Yes, what is the oxidation state? Scandium is what? It is 3D1. Yes. What is the oxidation state of this 3D1? 4s2. Right? The electronic configuration. Now, when it undergoes plus 3 means all these 3 electrons are lost. So, it will be 3D0. Right? So, the number of electrons, how many they are? 0. So, if you calculate the magnetic moment, mu is equals to n into n plus 2, it will be what? It will be 0. Okay, so the magnetic moment is 0. Suppose now I take titanium plus 2. Okay, can you calculate for titanium plus 2? I want the value for titanium plus 2. Titanium, then find out for Mn plus 2, then find out for nickel plus 2, cobalt plus 2. So tell me the values. Yes, titanium. What is the electronic configuration for titanium? Titanium is what? It is 3d2 4s2. Okay, 3d2 4s2. That is argon 3d2 4s2. So we are just interested in one in what? We are interested in the outermost electrons. Okay, we are interested in the outermost electrons. So we'll take this 3d2 4s2. So titanium plus 2 means how many electrons? 2 electrons. Okay. Now mu is equals to, now write the, so in the d5 system you have only 2 electrons. So these are unpaired. So n is equals to 2. Okay. So 2 into 2 plus 2 is equals to. So what will be the answer? So square root of 2 plus 2 is 4. 4 to the 8. So square root of 8. What will be the answer? So after calculating, okay, after calculating, you will get the answer as what? Titanium plus 2. So square root of 8 is 2.84. Are you getting the same? So the magnetic moment value you will get as 2.84. Now similarly do it for Mn plus 2. Give me the answers for Mn plus 2, students. Did you understand? Yes. So magnetic moment, very important, asked for exams. Calculate the magnetic moment. Okay, for any of the ions like this, for 2 marks, this question is asked. And you have to write the value, that is, the value is what? 2.84 Bohr magnetum. So like this, you have to mention. Okay, you have to mention. That is, you have to write the units also. That is 2.84 Bohr magnetum. So can you calculate for Mn plus 2? Give me the answer for Mn plus 2 now. Give me the answer for Mn plus 2. Yes. Okay. I've got one answer, 5.71. Okay. So let me tell you, Mn. Okay. Mn is what? Mn is 3d5 4s2. Okay. 3d5 4s2. Now, Mn plus 2 means these two electrons are lost. So how much it is? It is 3d5 system. Okay. Now, when you are writing the electronic configuration, okay, when you're filling up the electrons, so the electrons will be filled singly. So how many unpaired electrons are there? 5. Okay, so use the formula mu is equals to square root of n into n plus 2. So square root of 5 plus 2. So it will be 5, 7. 5 sevens are 35. So take the square root of 35. See how much you'll get. Let me also see square root of 35. Square root of 35. 5.91. Are you getting the same? 5.91. So 5.91 Bohr magnetum. Okay, 5.91 Bohr magnetum. Okay. Similarly for nickel, nickel plus 2, nickel plus 2. Nickel is 3d8 4s2. Okay, nickel plus 2 means 3d8. So write the electrons 1, 2, 3, 4. First singly, then 5, 6, 7, and 8. So how many unpaired electrons? 2. So 2, 2 plus 2. So it will be 2 into 4. It is 8 again. Okay, so square root of 8, square root of 8 is 2.82 Bohr magnetum. Are you getting the same? Yes, Nafiza has got the same. Good. Okay, let us move for the one more I had given you, right? Cobalt. Okay, cobalt plus 2. Again, 3d7, 4s2. Because nickel is, this is 27. So 3d7, 4s2. Yes. So how many? Plus 2 means 3d7 system. Right. So write the electrons, fill up the electrons. So it will be 1, 2, 3, 4, 5, 6, and 7. So it will be 1, 2, 3 electrons. So 3 electrons. So square root of 3, 3 plus 2. So it is square root of 3, 5. So 15. Take 15 square root of 15. Square root of 15 is 3.87 Bohr magnetum. Are you getting the same? So did you understand? 3.87. Did you understand? Yes, how to calculate the magnetic moments. Very important. Asked. Okay, it is asked for exams for 2 marks. Is it clear? Yes. So 3.87 Bohr magnetum. Okay, fine. So magnetic property also we have discussed. So like this, the question is asked. Calculate the spin magnetic moment of, so like this, the question can be given. Okay. So like this. So I'll calculate the, I'll give you, so I want the answer from you all. Mag, uh, okay. So calculate the magnetic moment of a divalent ion in aqueous solution if its atomic number is 25. Okay, give me. Give me the answer for this. Give me the answer for this. How will you solve this? So I want the answer. Okay, no, fine. Yeah, it is Mn. Okay, but you have to write now. Calculate the magnetic moment of that divalent ion. Okay, so means what? So as atomic number is 25, the element is what? It is Mn. Okay, so write the electronic configuration. It will be 3d5 4s2. Right. So Mn is divalent in nature. Divalent means plus 2. So it will be 3d5. Okay. So for 3d5. So write the 3d5 system. So it will be 1, 2, 3, 4. 1, 2, 3, 4, and 5. So number of unpaired electrons are 5. So mu is equals to square root of n into n plus 2. So 5, 5 plus 2. So it is 5 into 7. So it is 35. So after solving, how much you're getting? It should be, no, it should be, so take square root of 35, take square root of 35, square root of 35 is 5.91 Bohr magnetum. Yes, correct. Shri Varuni and Nafisa has answered it right. Good. Okay. Next question. Okay. So this is bit applicative type. Okay. Copper ion is diamagnetic. Copper ion is diamagnetic, whereas cupric ion, is paramagnetic. Is paramagnetic. Explain. Explain. Can you explain this? Cuprous ion. What do you mean by cuprous? Copper. Okay, first we'll write the electronic configuration of copper. Copper is 29. So it is 18, 3d10 and 4s1. Okay. Now, can you tell me what is cuprous? Cuprous means copper is in +1 state. Okay, copper is in +1 state. And cupric. So cuprous means copper is in +1 state and cupric is copper is in +2 state. So write the this now. Now cuprous +1 means it will be 3d10 system. And cupric +2 means it will be 3d9 system. So write the electrons 1, 2, 3, 4, 5, and here 1, 2, 3, 4, 5. So filled up the electrons. So here it will be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so it is 3d10. Now here 1, 2, 3, 4, 5, 6, 7, 8, 9. So how many? 1 unpaired electron. So if you write here, mu will be equal to 0. Here mu will be equal to square root of n into n plus 2. So calculate n is equals to 1. So 1, 1 plus 2. So it will be 3. So square root of 3 is how much? Yes. So take square root of 3. It is 1.1 into 3. 3. So square root of 3 is 1.73 Bohr magnetum. So what is asked? So cuprous ion is diamagnetic, whereas cupric ion is paramagnetic. Yes. Why? Explain what is the reason? Because in cuprous ion, okay, number of electrons is 0. And in cupric ion, number of electron is 1. Therefore, cupric ion is paramagnetic in nature and cuprous ion is yes. Yes, Sri Varuni has answered it correct because there is one unpaired electron. Cu is D shell is filled. Yes, good. Okay, very good. So like this, you have to explain. Okay, so like this, questions are asked on this what magnetic behavior. Okay, next property is formation of colored ions. Okay, formation of colored ions. Okay. So next is formation of colored ions. So whatever the transition metal are all these transition metal compound, these are colored. Okay, they are colored in their solid state as well as in their aqueous state. Okay, now because they absorb, okay, they absorb a particular radiation from visible region of light and thus they exhibit light. Okay, so what is done? These transition metal ions, they exhibit the color property. What is the reason? They exhibit both in transition state, in a color solid state as well as in the aqueous state. So they absorb the light. Okay, they absorb the particular light frequency of radiation from physical visible light and they transmit they will transmit, so they will take the light and they will transmit the light, okay, in minimum or remaining is called complementary to the color which is absorbed. So it will be complementary to the complex will show the complementary of that color. Okay, so like this the complex are colored. So this is the transition elements, they are exhibiting color property because they will require very less amount of energy to undergo excitation. So they will absorb the radiation from visible and they will transmit it to the, so whatever the complex it is absorbed, it will show the complementary color. Okay, so the absorption of radiation, why it is so? It is the absorption of radiation, it takes place due to the DD transition. It takes place, why? It takes place due to the transition of electrons. Okay, so the transition of electron takes place from lower energy to higher energy. So the electrons from lower energy d orbitals will undergo DD transition to higher energy. So whenever you have lower energy and you have higher energy, okay, so what will happen? The electron which is there here, so what if you supply energy, if you supply higher energy, okay, so it will get excited to the higher energy. Okay, now this, so it will undergo from a lower to higher. Now this excited electron, it has to come back. Okay, when it has to come back, it will come back in the form of radiation. Okay, it will give out radiation and this will fall into the visible region. Okay, it will fall into the visible region and it will show the complementary color. So what are the different ions? Okay, and there are different configuration colors. So scandium +3, +3 and titanium +4. Okay, so the configuration is 3D10 and these are always colorless. Okay, these will always have colorless. Okay, because they are having zero. Okay, they will have zero electrons. Okay, if there is unpaired electron, then only it will undergo DD transition. Okay, if there are unpaired electrons, if there are zero electrons, okay, or completely filled electrons, okay, if there is zero electrons or completely filled electron, then the complex will be colorless. Then titanium +3 and vanadium +4. It will have 3D1, okay, and it is purple or it will show blue color. Then vanadium +3, it will show D2 and the color of the complex will be green. Okay, then vanadium +2 and chromium +3, it is 3D3 and the color is violet. Then Mn +3, it is 3D4 system, the color is violet. Then chromium +2, 3D4 system, the color is blue, shown by the complex. Then Mn +2, 3D5 system, the color shown by the complex will be pink. Then Fe +3, it is a 3D5 system, the color shown by the complex will be yellow. Then when you have Fe +2 system, the color complex is 3D6 and the color of this is green. Then when you have cobalt +3 and cobalt +2, it will have 3D6 or 3D7. The color will be blue and pink. Okay, if you have a 3D6, you will have blue color. If you have 3D7, you will have pink color. Okay. Then when you have nickel plus 2, that is 3D8 system, the color of the complex is green. Copper plus 2, 3D9, the color of the complex is blue. Then last, Zn plus 2, 3D10, again it will be colorless. So whenever you have D0, that is will be colorless system. Is it clear? So color property is shown by the transition metal ions. Why it shows color property? Due to the DD-TD transition. That is, it undergoes DD transition of unpaired electrons. Okay. And the electrons will go from a lower energy to higher energy, and it will absorb the visible and it will absorb the light from the visible region, and it will show the complementary color to that of the complex. Okay, so this is the color property which is shown by the transition elements. Okay, so whenever the ions, now here which are the ions which are empty? Yes, you can see that scandium plus 3, titanium plus 3. Okay, and if you have palladium plus 5. Okay, so the if the ions are completely filled or they are 0. Okay, if there is no electrons, if there is empty d orbitals, or if the ions are completely filled, then what will be the color of the complex? Yes, they will be colorless. Remember that whenever you have zero system or you have completely filled system, then the color of the complex is colorless. Okay, and whenever you have what? You have unpaired electrons. Okay, then you will have a colored complex. Is it clear? Are these properties clear? Yes? Up to here, everything is clear? Yes? Is it clear? Okay. Others have understood? Okay, fine. So, we are left with the one more property, that is two more. No, there are two more properties, that is formation of complex compounds, then catalytic properties. Okay, so these are some of the properties which are shown by the transition elements, then formation of interstitial compounds, then alloy formation. Okay, so four more properties are there. So these properties we'll be discussing in the next class. Okay, fine. So I shall end the session here. Okay, so we'll meet in the next class. So whatever things have been told today, please go through that. If you have any doubts, you can come to me in the next class. Okay, fine. So I'll end the session here. We will meet in the next class. Thank you.